All right, welcome to Common Assessment number 4, RETEACH of Parallel Lines and Transversals. I found this colorful parallel lines cut by a transversal to tell you more about the theorems that we learned and to kind of color code and visualize it for you. So we have corresponding angles. Those are the red angles. There's actually 4 pair, but those are the red ones. That's all about location, location, location. And here, they're within this parallel line here, and the transversal, they're in the top right, and in this parallel line and transversal, it's also in the top right. So they could be in each corner. If you'll notice here, those are going to be equal to one another. They're equal. They're both obtuse in this drawing. Remember, you told me you could tell the difference between acute and obtuse. They're both obtuse. That would make them equal. Then we have alternate exterior angles, and those are going to be our orange ones. They're on the outside of the parallel line, so everything inside would be interior, and everything outside would be exterior. So my orange ones are exterior, and they're on different sides of the transversal. They're on alternate sides. And you'll notice that they're congruent. They're equal to one another, and the orange ones are acute. Then we have vertical angles. We learned vertical angles in the previous lesson. Those are my yellow ones here. And they're equal to each other as well because they're directly across from each other. They're formed by the intersecting lines. So these are, and there's actually 4 pair of those as well. These two are both obtuse, and since they're both obtuse, they're equal. Then we have our green angles, our same side interior angles. They're on the same side of the transversal, and they're in between the parallel lines. Now, these aren't equal to each other. They equal 180. They add up to equal 180. And you can see that this one is obtuse and this one is acute. So I have a mix of obtuse and acute, and that's going to give me equal to 180. Then we have alternate interior. Alternate interior, those are my blue angles here. They're inside the parallel lines, and they're on different sides of the transversal. They can't be adjacent. If they're adjacent, like the blue one and the green one, that would be called a linear pair, which we also learned. Okay, they add up to 180. But alternate interior angles, they're both acute. That means they're equal to each other. They're equal to each other. And then our last pair that we looked at were same side exterior angles. Those are our purple ones. They're on the outside of the parallel lines, and then they're on the same side of the transversal. So these are both on the right. Okay, one of them is acute and one of them is obtuse. That makes them supplementary. That means they add up to 180 with each other. Okay, so this is a rundown of our parallel lines cut by a transversal. So let's move on to some examples, and these are going to be the type of problems you see on the retest. Okay, we're given M is parallel to N. Remember, the symbol right here means parallel. We want to find the value of X. So my 2 parallel lines, those are horizontal, and my transversal line is intersecting them. So I want to take a look, and I notice here's my X, here's my 68. So I notice they're on the outside. They are exterior angles. They're exterior angles, and they're on the same side. So that classifies them as same side exterior angles. And if I go back, my same side exterior angles add up to equal 180. So they're supplementary. My X is obtuse, my 68 is acute. So X plus 68 is going to add up to 180. They add up to equal 180. And then I just subtract 68 from 180. Got to borrow. And I get 112 degrees. So my X is going to equal 112 degrees, and that should be consistent because we said it was obtuse. 112 degrees is an obtuse angle. Okay, given m is parallel to n, find the value of x. All right, well, here I have a 20-degree angle, and here I have an x. I notice that they're both acute. That tells me they're going to be equal to each other. But before I do that, I need to identify them. So 20 is inside, and x is outside. So it's not my interior angles or my exterior angles. And the only one that's not interior or exterior are corresponding angles. Corresponding. So they're in the same location because they're in the bottom right of the first one and the bottom right of n of the second one. So that means they are congruent, and that means that my x is also going to equal 20 degrees. Given L is parallel to M is parallel to N. So here I have 3 parallel lines, and I want to find the value of x. So I'm looking at x, and I'm looking at 128. And if I look at the parallel lines, so x is a part of M, 128 is a part of N, so I'm looking at those parallel lines and the transversals. So I'm kind of highlighting it. Kind of helps me focus where I need to look because that L is not really necessary for us for this problem. And what I notice is that x and 128 are on the outside, so they're exterior angles of M and N. And they're on the same side. So these are same side exterior angles, which means they add up to equal 180. So x and 128 add up to equal 180, and I would subtract 128 from 180. Okay, so one of the things we notice too is that the x is acute. So if I borrow, I get 52 degrees, which makes sense because this one is acute and 128 is obtuse. So I have an acute angle and an obtuse angle. So x is 152 degrees. Okay, given M is parallel to N, find the value of x. Now this one's a little bit different because it's rotated 90 degrees. So my parallel lines are running up and down and my transversal to the side. It's okay, we could still look at it. I have x and 124 degrees. I see they're both interior angles. They're inside and they're on the same side. So they are same side interior angles. And same side interior angles add up to 180 because I notice x is acute, 124 is obtuse. So x plus 124, they're going to add up to equal 180. And then I just have to subtract 124 from 180. And my x is going to equal, gotta borrow, 56 degrees. So my x is going to equal 56. Okay. Given M is parallel to N, find the value of x. Okay, so I have x minus 3 and 8x plus 3. And what I notice is one of them's outside and 8x plus 3 is inside. So I want to see if they're corresponding. And I can see that they are not. But I also notice that x minus 3 is acute and 8x plus 3 is obtuse. That means they're going to add up to 180 with each other. So x minus 3 plus 8x plus 3, they're going to add up to 180. They're going to be supplementary because I have one of the obtuse angles and one of the acute angles. When I combine my terms, I get x and 8x. That gives me 9x. When I have negative 3 and 3, ooh, they cancel out. They make a 0. And I get 9x is equal to 180. We're going to divide by 9. And my x is equal to 20. So even though I didn't have an official angle pair here, I'm still able to find out what x is because I know two things. One, the angles are either equal to each other, or 2, they're going to add up to 180 with each other. Okay, given m is parallel to n, find the value of x. So I have 5x plus 9, and I have 7x minus 9. And what I notice is that I have 1 on the interior and 1 on the exterior. So given that I know I don't have interior angles or exterior angles, what I do have is I don't have a specific angle pair. I notice 5x plus 9 is acute and 7x minus 9 is obtuse. So that means they're going to be supplementary. So that means that 5x plus 9, when added to 7x minus 9, they're going to add up to equal 180. They're going to be supplementary, and that's because 5x plus 9 is acute and 7x minus 9 is obtuse. So when I combine my terms, I have 12x, 5 and 7 is 12, 9 minus 9, that's 0. So they cancel out, equals 180, and then I'm going to divide by 12. Okay, well, I notice they're both even, so I'm going to divide that by 2. So I get 90 and 6. They're both even. I can still divide by 2. I get 45 and 3. And then they're both divisible by 3. That gives me 15. So my x is equal to 15. Now it's your turn to impress me on the test.